So in this video, we're going to focus on adding mixed numbers and improper fractions with unlike denominators. The first problem we have here is 5 3/4 plus 3 1/12. Now, as always, I always look at my denominators. We see that they're 4 and 12. Since they're both different, we cannot start adding until we find the least common denominator. Now, on the side, I'm just going to write 4 and 12, and I'm going to list out the multiples. I'm going to start with my smaller number. So I see 4, 8, 12. Now, I can continue, but I notice I have 12 as a multiple of 4, and my other denominator was 12, which is great. This is telling me I only need to change the denominator in 5 3/4. So now, as I do this, I'm going to do the normal process. Even though I have a mixed number, I'm still going to include my whole number. I'm not going to forget about that whole number. And I determine that my least common denominator is going to be 12 for this entire problem. And I'm even going to write 12 down here in my answer, so I know that I'm always using 12 as my denominator. Now, my next step, I'm going to look at 5 3/4. Here, I'm going to ask myself, 4 times what number gets me to 12? Well, 4 times 3 is 12. So if I multiply my denominator by 3, I'm going to multiply my numerator by 3 as well. So now 3 times 3 is my new numerator. This is showing me that 5 9/12 is equivalent or equal to 5 3/4. Now I look at 3 1/12, and I notice my denominator is already 12. This is great. So all I need to do, I just rewrote this fraction again just to help me out and set this problem up nicely. Now I notice my denominators are the same. They're both 12. So I can simply add my numerators, 9 plus 1, which is 10. Now, since we are given a mixed number, we cannot forget about these whole numbers. So now we can simply just add 5 plus 3, which is 8. Now, 8 10/12 is our answer. This is a great answer. However, I look at 10/12 and I think to myself, I wonder if I could divide my numerator and denominator both by something. Now, I see that they're both even numbers. So I actually can divide my numerator by 2 and my denominator by 2. This is going to create a new equivalent fraction. Now, we saw at this step here, I can create an equivalent fraction by multiplying my numerator and denominator by the same number. I can also create an equivalent fraction by dividing my numerator and denominator by the same number. So if I do that, my whole number is going to remain the same. 10 divided by 2 is 5, and 12 divided by 2 is 6. Now, 8 5/6 is equivalent to 8 10/12. Both 8 10/12 and 8 5/6 are correct answers. However, when we begin solving some word problems and seeing these fractions in real life situations, oftentimes when you represent something that is a mixed number, you oftentimes see it written in simplest form. And that means this process here of finding an equivalent fraction by dividing my numerator and denominator both by the same number. Now let's try this problem here. We have 8 1/2 plus 4 5/8. So our goal is to find the sum of these two fractions. As always, I look at my denominators. I see I have 2 and 8. I'm going to write them on the side, start listing out my multiples. I'm going to start with my lowest number. So I have 2, 4, 6, 8. I'm going to stop there. This is great. I have 8 and 8, and I notice that one of my denominators is already 8. So this is telling me I only need to change 8 1/2. Now, I'm going to still rewrite everything anyway. Notice I'm including my whole numbers. I recognize that my denominator is going to be 8 throughout this entire problem. So now I'm going to look at 8 1/2. 2 times what number is 8? Well, 2 times 4 is 8. So if I multiply my denominator by 4, I multiply my numerator by 4 as well. 1 times 4 is 4. So this is telling me that 8 1/2 is equivalent or equal to 8 4/8. Now 4 5/8, my denominator is already 8, so I don't have to change anything here. So now I'm just going to include 4 5/8. Now my next step. I notice my denominators are finally both the same, so I add my numerators. 5 plus 4 is 9. And my whole numbers here, 8 plus 4 is 12. Now 12 9/8 is the sum of these two fractions. Now, looking at this answer, I noticed something a little funky, a little strange about my answer. I notice I have a mixed number, but within my mixed number, I also have an improper fraction of 9/8. Now, oftentimes you don't see a mixed number with a larger numerator. So I'm going to actually take this fraction apart and represent it in another form that's easier for people to understand. So now let's do this part in red. So I'm going to take 9/8. I'm going to just write 9/8 on the side. What I'm going to do here is actually write this as a mixed number. So I'm going to take this improper fraction and convert it to a mixed number. Now looking at 9/8, I notice I can actually separate it to 8/8 and 1/8. And 8/8, 8 divided by 8, we know is 1. And this is also equivalent to 1 and 1/8. So notice here, we tore apart 9/8, 8/8 plus 1/8, which is going to help me determine my mixed number. Now, this is excellent, and I'm going to use this to help me find my final answer. So now, on the side here, I'm going to take my whole number of 12, and I'm going to add this to 1 and 1/8, which we determined was equivalent to 9/8. Now, my final step here is I'm going to add my whole numbers. 12 plus 1 is 13, and 1/8. Now, 13 and 1/8 is exactly the same or equal or equivalent to 12 and 9/8. However, if you were to describe something to somebody, 13 and 1/8 is much easier to understand and interpret when you have a mixed number that consists of a whole number and a proper fraction. When you have a mixed number that consists of a whole number and an improper fraction, it looks a little strange and it's a little bit harder to interpret. So if we change this representation and writing it as a true mixed number with a whole number and a proper fraction, this is much easier to understand your final answer. Okay, we have another problem. This one's a great problem because we have a mixed number and we have a proper fraction. Doesn't matter what's given to you, it's still the same process. So just like we've been doing, we look at my denominators always first. I see we have 5 and 10. Now I'm going to write on the side my multiples, start with the lower number, 5, 10, and right away I stop because I'm like, wait, that's great, I have 10 and 10. And what this is telling me is, in fact, my denominator throughout this problem is going to be 10, but I only need to change one fraction. Now, some of you might use 50 as your denominator. That is correct. That's totally right. However, then you're going to be changing both fractions. But if I do the least common denominator, then I only need to change one fraction, which makes my life a little bit easier. So I'm just going to rewrite 3 and 7/10. Now I'm looking at 3/5, and I see 5 times 2 is 10. So if I multiply my denominator by 2, I multiply my numerator by 2. So 3 times 2 is 6. Now my last step, I'm going to add my numerators. 7 plus 6 is 13. And I have a whole number here of just 3. I'm going to just bring this whole number into my final answer. I can't forget about that. So I have 3 and 13/10. Uh-oh, this looks similar to the last problem. I notice I have a mixed number with an improper fraction in it. I'm going to take this improper fraction and I'm going to tear it apart. I'm going to represent my improper fraction as 10/10 plus 3/10. And I know that 10/10, 10 divided by 10 is 1, and 3/10 can stay exactly the same. And notice all I did here was convert this improper fraction to this mixed number, which notice it's both exactly the same. Even though they're represented in different ways, it's still showing and representing the same value. So now I'm going to take my whole number of 3, and I'm going to simply add it to 1 and 3/10, which now I add my whole numbers. 3 plus 1 is 4, and 3/10 as 4, and 3/10 as my final answer. And notice, yes, this is an extra step here, but representing my answer as a mixed number with a whole number and a proper fraction is much easier to interpret and understand than representing my answer with a whole number and an improper fraction in it. So I encourage you to take this extra step and rewrite your answer just like this. Now, there's a few options on how to solve problems like this. Notice we have a mixed number and we have an improper fraction. I'm going to go through 3 different ways to solve this exact same problem, and then you can decide which way you like the best. So here it says solve the problem in the given format. I'm not going to change this. I'm going to keep my mixed number the same. I'm going to keep my improper fraction the same. Right away, I see my denominators are different. So let's list out my multiples. 2, 4, 6. Now, right away, I found that 6 is my least common denominator. Now, I'm going to rewrite on the side my fractions. Notice here my denominator is going to be 6 throughout this entire problem. I have 1 as my whole number. Can't forget about that. I recognize 2 times 3 is 6. So if I multiply my denominator by 3, I multiply my numerator by 3. 1 times 3 is 3. Notice this is showing me 1 and 3/6 is equivalent to 1 and 1/2. Now I see 8/6, it's exactly the same. 6 is the denominator, so I'm just going to bring this over here, just to include this when I start my adding. Now, just like we've done all along, we're going to add my numerators because my denominators are the same. 8 plus 3 is 11, and can't forget about my whole number. Now, just like we said before, we have a mixed number that consists of a whole number and an improper fraction. Looks a little crazy. So let's do this part in green. I'm going to take 11/6 on the side. I enjoy separating this improper fraction. It makes it a little bit easier to interpret. So now I have 6/6 plus 5/6. Well, 6 divided by 6, or 6/6, is the same as 1 and 5/6. Now I'm going to take this and I'm going to add this to my current whole number here of 1, plus 1 and 5/6. Now 1 plus 1 is 2, and 5/6 as my final answer. Now, 2 and 5/6 is our answer here, and we're going to solve this in 2 other ways. And you're going to find that no matter what way you select, you will always get the same answer. So let's take a look at this way. Option 2 says change both fractions to improper fractions. So now I have 1 and 1/2, which 2 times 1 is 2, plus 1 is 3. So 2 times 1 is 2, plus 1 is 3. That gave me my numerator with the same denominator here of 2. Now 1 and 1/2 can also be represented as 3/2. Now just to prove that this is another way to represent this, now 1, we can represent 1 as 2 halves, or 2 divided by 2, plus 1/2, which also now gives me 3 halves. So again, there's several different ways to convert your mixed number to an improper fraction. Here I have 3 halves, and now I have 8/6. Notice I have 2 improper fractions. So I notice, just like the last problem, we want my denominator to be 6. So I'm going to keep 8/6. 2 times 3 is 6, and 3 times 3 is 9. Now I can add these together. 9 plus 8 is 17. And I have 6 as my denominator. Now 17/6, let's see how I can convert this. So I have 6/6, and it sounds like I can make another 6/6. 6 plus 6 is 12, plus 5/6. So 6 plus 6 is 12, plus 5 is 17. So notice I have 2 wholes and 5/6. Wow, take a look at this, 2 and 5/6, that's the same answer for my previous problem. So this is just another way that you can solve this problem by converting everything to an improper fraction. You can also choose to leave your answer as an improper fraction. That is completely fine as well. Now, the last way is change both fractions to a mixed number. So I'm going to take 8/6, then I know, okay, let's see, I have 6/6 plus 2/6 gives me 8/6. So I have 1 and 2/6. So I have 1 and 2/6, and 1 and 1/2. This looks very familiar to problems we already solved. We know here that my denominator throughout this problem will be 6. We already discovered that. So here I have 1 and 2/6. 2 times 3 gave me 6. 1 times 3 is 3. Can't forget about my whole number there either. Notice to always include these whole numbers throughout your problem. Add my numerators. 3 plus 2 is 5. Add my whole numbers. 1 plus 1 is 2. And take a look at that. We got 2 and 5/6 again. Now, these are 3 different ways to solve mixed numbers and improper fractions. These ways work when you are adding and subtracting. I encourage you to try them all and pick which one you like the best and stick with that method. Depending on what's given to you, might also determine what method you select to do when you're solving each problem.